is interesting. A civil engineering contractor has just received a sizable contract and plans to subcontract from 3 firms. Each job is sufficiently large and any firm can take only one job. The table below shows the bids as well as the cost estimates. Which are in lakh of rupees for doing the job. Externally as well as internally. Not more than 3 jobs can be performed internally. Find the optimal assignment that will result in minimum total cost. Right. So this is the question that they have given. We also have some data. There are 6 jobs. So here we have 1, 2, 3, and this is internal. Right, so 44, 67, 41, 53, 48, and 64. 46, 69, 40, 45, 45, and 68. 43, 73, 37, 51, 44, and 62. And for internally we have 50, 65, 35, 50, 46, and 63. So now this is the problem. So if we read the problem again, so if you'll be understanding that now, let's understand the problem first. A civil engineering contractor has received a very good contract, right? And it is a very good big contract, and what he is willing to do is that few of the he is willing to plan the subcontract that subcontract for the 3 firms. So उसको जो contract मिला है वो उसको क्या करने वाला है, आगे subcontract करना चाहता है 3 firms के साथ, right? Now each job is sufficiently large and any firm can take only one job. So that is the beauty of this. So which makes this as a assignment problem. So now the table shows the bids as well as the cost estimate. So everything that has been written in the table is in lakh of rupees. So that is 44 lakh, 67 lakhs. No, this particular cost that has been given in the table are for the external as well as the internal internal jobs. Now, not more than 3 jobs can be performed internally. Find the optimal assignment that will result in the minimum total cost. Now, there are these three firms are the external firms to which is going to give the jobs, and all these are the jobs, right? So 1, 2, 3, 4, 5, 6 are jobs. So if firm 1 is doing that particular, if firm 1 is doing job number 4, so it is going to require 53 lakh rupees. Similarly, if firm number 2 is willing to do job number 6, that is going to require 68 lakh of rupees, and likewise. So he can also do the internal search particular jobs internally, and for internally, the costs are also given. So if there is an internal internal company, or he himself is doing that job, so that particular cost is also given. So 3 jobs are to be given for 3 firms, and here you will have to understand that not more than 3 jobs are to be done internally, right? So can be performed internally. So 3 can be done internally, and the rest 3 can be done by the firms 1, 2, and 3. Now, if you see, this is an unbalanced transportation problem, but it is now, no, it won't be requiring a regular aspect of unbalanced, a regular method that we follow for the unbalanced assignment problem. So here, what we'll have to do is that we can consider the internal company. We can consider 3 internal companies, say I1, I2, and I3, and that particular 3 external companies and 3 internal companies can be 6, right? 3 plus 3 will be 6, and here we have the number of jobs at 6. So 6 is equal to 6 will be the balanced assignment problem, right? So here you do not have to go with the conventional method of putting 0 unit cost. So here in the problem only they have said that the 3 jobs can be done internally. So why not to will be following the same important statement, and that statement will be further useful for us to design this problem. So I've specifically taken this problem. So what we can do is now we can consider this I1. Internal, this can be considered as I1 company, right? And we can particularly right, so here it can be I2, here it can be I3, right? So now the internal companies will have the same, they will be requiring the same amount of same cost for completion of the job. So here also the the amount will be same as I1. So 50, 65, 35, 50, 46, and 63. And here again it will be 50, 65, 35, 50, 46, and 63. So likewise, you have got now 6 firms, 1, 2, 3, 4, 5, 6, and you have 6 jobs, that is 1, 2, 3, 4, 5, and 6, and this becomes a balanced assignment problem. And here you can now get yourself involved and try solving this balanced assignment problem. So we'll be starting with the row reduction and the column reduction, and then we'll be seeing how to move ahead. So if we do row reduction, why the row reduction is to be done? Because we want a 0 in every row. Why column reduction is to be done? We want at least 1 0 in every column. So that is the strategy that we have decided according to the Hungarian method, right? So 6. So if we do row reduction, we have the smallest value as 41 in row number 1. So 44 minus 41 comes out to be 3. 67 minus 41 comes out to be 26. 41 minus 41 comes out to be 0. 53 minus 41 comes out to be 12. 48 minus 47 comes out to be 7, and 64 minus 41 comes out to be Yeah, it is 23. Similarly, in row number 2, the smallest value that we have is 40. So let's move ahead. So 46 minus 40 is 6, 69 minus 40 is 29, 40 minus 40 is 0, 45 minus 40 is 5, 45 minus 40 is 5, and 68 minus 40 is 28, right? In row number 3, the minimum value that we have is 37, right? 37 is to be subtracted. So what is, yeah, 43 minus 37 is 6, 73 minus 37 is 36, 37 minus 37 is 0, 51 minus 37 is 14, 44 minus 37 is 7, and 62 minus 37 is 25. Similarly, here for the smallest value is 35 in the row I1. So 50 minus 35 is 15. 65 minus 35 is 30. 35 minus 35 is 0. 50 minus 35 is 15. 46 minus 35 is 11. And 63 minus 35, it comes out to be 28, right? So all these values will be same as the row values are constant here. So 15, 30, 0, 15, 11, 28. I'll be trying to okay, so a small I'll be drawing here. I'll have to repeat it on the next page, but that is okay. So we are going to do column reduction now, because we don't have 0 in every column. We have one column which consists of all the values as 0, but we do not have all the columns which consist at least 1 0. So when we do column reduction, so for column number 1, 3 is the minimum value. So 3 minus 3 is 0, 6 minus 3 is 3, 6 minus 3 is 3, 15 minus 3 is 12, 15 minus 3 is 12, and 15 minus 3 is 12. Nextly, the minimum value that we have is 26. So 26 minus 26 is 0, 29 minus 26 is 3, 36 minus 26 is 10, 30 minus 26 is 4, 4, and 4 here, right? So next column we can repeat because it consists of all zeros. For the next column, the minimum value is 5, 12 minus 5 is 7, 5 minus 5 is 0, 14 minus 5 is 14 minus 5 is 9, 15 minus 5 is 10, 10, and 10 here. The next minimum value that we have here is 5, right? So 7 minus 5 is 2, 5 minus 5 is 0, 7 minus 5 is 2, 11 minus 5 is 6, 6, and 6 here. The next minimum value that we have is 23. So 23 minus 23 is 0, 28 minus 23 is 5, 25 minus 23 is 2, 28 minus 23 is 5, 5, and 5 here. So I think no one has a problem after this step. Let's move towards row scanning and column scanning in the same way here. So here we had or should we go to the next page? Okay, I'll be going to the next page. I'll be repeating this table here so that we do not get confused and everyone understands. Right, so it was 007, oh sorry, 0000720 330005. Next it was 310922, 12 4 0 10 6 5, same 10 12 4 0 10 6 5. Here it is 12 4 0 10 6 and 5, right? So 1 2 3 4 5 6, 1 2 3, I1 I2 and I3. right? So let's do row scanning and the column scanning. So first row we have multiple zeros, not possible. Row number 2 we have multiple zeros, not possible. Row number 3 we have a single zero, and it is possible here to mark a square, and we'll be drawing a vertical line. Row number 4 it is not possible. Row number 5 is not possible. Row number 6 it is not possible. Now row scanning we have finished. Let's do column scanning. In column number 1 we have a single zero here, so we are going to mark a square and we are going to draw a horizontal line, right? So in row number sorry, in column number 2 we do not have a single zero. Similarly, in column number 3 all the zeros are cancelled. In column number 4 we have a single zero, and the assignment is possible here, so we'll be doing a square matrix and we are going to draw a horizontal line. So if we check out, all these zeros are cancelled, and we have drawn the minimum lines that are passing through all these zeros, right? Now we are going to check whether the obtained solution is optimal solution or not. So the number of squares that we have is number of squares is equal to how many? It is 1, 2 and 3, right? And number of rows or columns that we have is equal to 6, right? So hence we'll have to iterate further, right? So hence we'll have to iterate further. So we'll have to find out the minimum value which is uncancelled, and no, the minimum value that is identified is 2. So minimum value is 2. Then we can reconstructing matrix, and what will we be doing? And perform row and column scanning. That is done, right? So let's move ahead, reconstruct the matrix. Three, 4, 5 and 6, right? So reconstructing this matrix, so we have the minimum value as 2. So 2 is to be subtracted from all undeleted cells, and 2 is to be added to the cells where the intersection of the lines is done. So let's first add 2 in the places where the intersection has happened. So 0 plus 2 here is 2, right? So the next intersection has happened at this particular cell, and okay, so all other cells no intersection is there. So all the cancelled cells I'll be writing first, or no, you can have your own strategy, doesn't matter. 3 minus 2 is 1, 10 minus 2 is 8. Here we have 0, 9 minus 2 is 7, 0, 0. 12 minus 2 is 10, 4 minus 2 is 2. Then we have 0, 10 minus 2 is 8, 6 minus 2 is 4, 5 minus 2 is 3. Similarly, you can repeat these because the values are remaining to be same. Just check with the values. All these values are remaining same, and hence we can do this. So now we have got a reduced we have got a different matrix, so we'll have to do the row scanning and the column scanning. So first row, again it is not possible because we have all the we have multiple zeros here. So not possible in second row, also not possible in third row, possible in our fourth, possible in our the fourth row. I'll be marking a square here, and I'll be drawing a vertical line. So not possible in row number 4, not possible in row number 5 as well. Let's move towards the column number 1. It is possible, we have a single zero, so we are going to draw a horizontal line here. Now in column number 2 it is not possible. Column number 3 it's already done. Column number 4 it is possible, right? So we are going to draw a horizontal line here. Column number 5, again it is it is possible. So here we have column number 5, and we have done a location here. So now you can see all the zeros are cancelled, and we have minimum lines that are passing through all these zeros. So we'll have to check with the optimality. number of squares that we have is equal to 1 2 3 4, right? And number of rows and columns that we have is equal to how many? It is equal to 6. So hence we'll have to iterate further, right? So now when we'll be moving ahead, the minimum value that has been identified again here is how much? Do we have the value less than 2 here? No, yeah, it is 2 again. So minimum value identified is 2. Reconstructing and scanning, right? So 1 2 3 4 5 and 6. So here we have 1 2 3 4 5 and lastly 6, right? So let's go with the intersection. So 2 plus 2 is 4 here, 2 plus 2 is 4 here, and 0 plus 2 is 2 here, right? So otherwise there is no intersection in other cells. Okay, so I'm going to fill up all other cells now. So it is 3 3 0 0 5 1 8 0 7 0 0, right? So subtracting 2, so here it will be 8 0 0 6 2 1, right? Similarly here it will be 8 0 0 6 2 1. Here again 8 0 0 6 2 1. So let's do the scanning here. So when we will be doing the scanning here, first row not possible. Just a second. First row it is not possible. Row number 2 is not possible. Row number 3 is not possible. Row number 4 is not possible. Row number 5 it is not possible. Row number 6 it is not possible. Let's do the column scanning. So for column number 1 it is possible. So we are going to do this and we are going to mark here, right? Again, what we have in column number 2 are the 3 zeros, not possible. Column number 3 not possible. Column number 4, is it possible? Yeah, column number 4 it is possible. So we are going to put a square and we are going to draw a horizontal line. Column number 5, is it possible? Yeah, it is possible. So we are going to mark a square and we are going to draw this. Again, let's do we have finished the column scanning, but with the first cycle of row and column scanning, all the zeros are not cancelled, right? So we'll have to repeat the row scanning and the column scanning again. So first 3 rows are already cancelled. Row number 4 5 and 6 we cannot do anything because we have multiple zeros. Again in column number 2 3 we have multiple zeros, but will column scanning is also not possible. So even if you repeat this column scanning and the row scanning, now no zeros are going to get cancelled. So what is to be done here? We want zeros to be cancelled, then only we can move ahead, right? So you can't, this is not the final solution, or you cannot count these squares here and then directly check whether it is optimal or not. Even to check for the optimality, all the zeros should be cancelled, right? So is it happening here? No, it is not happening. All the zeros are not cancelled, hence we cannot go for the optimality check, right? So what we'll have to do here is, now we'll have to go for the it is arbitrary allocation or arbitrary assignment of the assignment we'll have to do here. So let's do it in the row scanning itself. So here I'm putting an arbitrary assignment here. So I've considered it as to be a row scanning. So if I'm doing this, I'll be drawing I'll be drawing a horizontal line, right? So again, all these zeros, if I'm doing the arbitrary, so even this 0 is to be cancelled because this is the part of this particular row. Now next arbitrary assignment is to be done here, and that particularly you can select any of these 2 pending zeros. I'll be selecting this particular 0 for me, and again, as it is a row scanning, so I'll be Now drawing a vertical line. So now we'll have to now you can check whether all the zeros are cancelled or not. Yeah, we have cancelled all the zeros. So the number of squares now that we have needs to be counted. So the number of squares that we have are 1, 2, 3, 4, and 5, and the number of rows or columns that we have are 6. So even with this we haven't got the optimal solution, hence we'll have to iterate further. I'm hoping that you have understood the step that we have done. I'm repeating the step. You have to cancel all the zeros to check for the optimality. So all the zeros are to be cancelled. If it is not possible, arbitrary assignment can be done. Right. So now just I'm going to repeat this entire this thing on the next page, so that you get an idea of what is happening. Right. So just a minute. So 4, 5, and 6. There's 1, 2, 3, 4, and 6. Just to be to be right, I'll be doing it again so that I do not make any mistake. So second, it is not possible. Third column, it is not possible. Fourth, it is possible. So I have drawn here and I have drawn horizontal line. Okay, fourth is done. Fifth is again possible. I have drawn a horizontal line and it is done. Right. So the arbitrary assignment was done afterwards. So this is the arbitrary assignment that I'm doing. I'll be drawing a vertical line, and this is the arbitrary assignment I'm doing, and I'll be drawing a vertical line. Now the number of squares that we had were 5. Number of rows or columns, this is the same step. I've just written it on the new page. It is 6, hence iterate. Now the minimum value that we have in uncancelled cells is 1. So minimum value is 1, right? Reconstruct and scan, right? So reconstructing and scanning the matrix. So for the reconstruction purpose, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, and 6, right? So 1, 2, 3, 4, 5, 6, 1, 2, 3, I1, I2, and I3 here. So 1 is to be added at the place where the intersection has happened, which is this cell. This is 4 plus 1, 5. Okay, so again 3 plus 1 is 4, 4 plus 1 is 5, right? Similarly, at this juncture, 8 plus 1 is 9, 2 plus 1 is 3. So all the intersection cells have been addressed. All the cancelled cells can be written as it is. Right, so here 8 minus 1 is 7. It is 0 here. It is 0 here. 6 minus 1 is 5. 2 minus 1 is 1. 1 minus 1 is 0. Similarly, I guess all this will be same, right? Because the values are same. Right, and now that we have got this matrix, we can perform the scanning. So let's do row scanning. row scanning, scanning of row 1 is not possible, row 2 is not possible, row 3 is not possible, row 4, row 5 and row 6 as well as are not possible. So let's do column scanning. Column number 1, yeah, we can do the allocation. So we have done the allocation here, and I'm going to draw a horizontal line. Column number 2, it is not possible. Column number 3, it is not possible. Column number 4, it is possible. So here we can draw a horizontal line. Column number 5, is it possible? Yeah, it is possible now. So we can draw a horizontal line. Column number 6, it is possible? No, it is not possible. So now what we are going to do, again row scanning is to be repeated. So row scanning of 3, 4 and 5, 4, 5 and 6 rows are not possible because it has multiple zeros. Even if we do the column scanning here, again we have multiple zeros. So what we need to do again here is the arbitrary allocation. So let's do an arbitrary allocation for this particular zero. That means this 0 and this 0 is going to get cancelled, and here I'm going to draw a vertical line, right? Again I have to do an allocation here. So I'll be doing an allocation here, and this 0 will get cancelled, and I will be drawing a vertical line. Lastly, here this 0 is remaining, and here also I need an assignment, right? So here there is only 1 0 in this row. Now I can do this, and again I'll be drawing a vertical line. So now the number of squares that I have is equal to how many? Number of squares that I have: 1, 2, 3, 4, 5 and 6. Number of rows and columns that I have is equal to 6, and hence the optimal solution is reached, right? So now we'll also have to write the answer in the form of a table. So for example, like subcontractor, which is who will be the subcontractor, which job he will be doing, and what will be the cost that will be involved, right? So here we have this particular thing. So subcontractor, right? So subcontractor 1, 2, 3, and there are 3 internal subcontractors, what you can say, or internally the job will be done. So here we have according to the first 1 को 1 मिलेगा, 2 को 4 मिलेगा, 3 को 5, I1 को कौन सा मिलने वाला है? I1 को मिलेगा 2, I2 को 3 and I3 को 6. So if we see the numerical starting given matrix, so the cost can be calculated here. So 44, it will be 65, 35 and 63. So the total cost will be the addition of all these. So will be 44 plus 45 plus 44 plus 65 plus 35 plus 63. So if we do the addition of all this, it will be 296 lakhs. The total cost that will be required will be how many? It will be 296 lakhs. So I'm